To find the moment of inertia of uniform solid cylinder or uniform solid disk that has mass distributed uniformly, consider we have here a uniform solid cylinder which has radius of capital R, that is capital R, the radius of this cylinder, and which has a total length of capital L, and it's rotate about its central axis, z. This is the central axis for this. This is the central axis, about the central axis z, rotate about central axis z. So we have to find its moment of inertia. To find its moment of inertia, first we have to divide it into many subshells, many cylindrical shells. Here this is the cylindrical shell. We have divided this uniform solid cylinder into, this is the small r, radius of that shell, and its thickness dr, small dr. First we have to find its density, the density of this small shell, we have to find. So for finding density, we know that first we have to find its volume. Volume of the shell is dV, which is equal to cross sectional area multiplied by its length, cross sectional area multiplied by its length. So dV is equal to L into dA. L is the length and dA is the cross sectional area. So cross sectional area is composed of the circumference of that cylindrical shell, that is 2 pi r, multiplied with dr, the thickness of that shell, that cylindrical shell, dr. So rho is equal to rho density. Density is equal to mass per unit volume, total mass per unit volume, mass of that small cylindrical shell divided by volume of that small cylindrical shell. So dm, if we rearrange this equation, this implies that dm is equal to rho into dv. So expressing dm, the mass of that small cylindrical shell, in terms of dr is the thickness. So dm is equal to, we have to put here from dv is equal to this L into 2 pi r dr, that is rho is equal to rho, dm is equal to rho from here, and in place of dv we put L into 2 pi r into dv. Now after finding the mass of the very small spherical shell, small cylindrical shell, sorry, now using equation of moment of inertia, we already have learned that Iz is equal to integration of r square into dm, that is the equation for what? For moment of inertia. So here we can fold dm from the last equation, which is d pi rho lr into dr. So put, this implies Iz is equal to, Iz here shows that moment of inertia which has the rotational axis z, about the rotational axis what? Z. So Iz is equal to integration of r square into rho L 2 pi r dr. As we know that density is constant, density cannot be changed due to rotation, and length also constant, which also cannot be change due to rotation, and 2 pi is obviously we know that that is a constant number, so we can take 2 pi rho and L common, take it common. So our equation will become Iz is equal to 2 pi rho L into r cube dr, and the limit for our integration will be from 0 to r. As we know that in from the figure, from here from the figure, that its limit is from 0 to r. This is 0 and this whole radius is capital R, so our integration limit is from 0 to r. So this r cube 0 to r into r cube dr, and this implies that Iz is equal to 2 pi and rho L, and after integrating this it will become r power 4 divided by 4, and after putting the limits it will become r power 4 divided by 4. So Iz is equal to pi by 2, cancel this 2 with 4, so pi by 2, so these 2 and 4 will be cancelled with each other, and this will become Iz is equal to pi by 2 rho into L r power 4. By using the total volume of the disk or cylinder, as we know that the total volume of the disk, as up to now we have discussed about the cylindrical shell which we consider, we have divided this whole cylinder or whole disk into small cylinders, small cylindrical shells. So now we are coming to the whole cylinder. The volume of the whole cylinder is V is equal to pi r square L. Pi r square L, this is the volume of the whole disk, and rho, as we know that rho density is equal to capital M divided by capital V, total mass of the disk divided by total volume of the disk, which is equal to capital M total mass of the disk divided by volume pi r square L. Iz is equal to pi by 2 dot M divided by pi r square L into L. Putting this equation, this density equation, into this equation, as you can see, this equation, that is here pi by 2 from there, and M divided by pi r square L from here, and L is the same, and r power 4. So after cancellating the same terms, we get into the point, we come here, Iz is equal to 1 divided by 2 capital M total mass of the disk multiplied by total radius of the disk. Iz is equal to half mr, which is the moment of inertia of the disk, of the uniform disk or uniform solid cylinder. So moment of inertia of any solid cylinder or any object, moment of inertia is not affected by the length. Mean length does not have any effect on the moment of inertia of any body. Here you can see that only mass and radius, moment of inertia depend on only mass, total mass of that object, and total radius of that object. So here for L is equal to 0, 1, 2, 3 flat body. So if L is 0, mean it doesn't have any length, means the flat cylinder. For flat cylinder For a flat cylinder, this inertia is the same, will be the same, Iz is equal to half mr, and for L is equal to 3, 4, 5 up to n number, mean the length, if the length is much increased, if the length is much high, then this will doesn't have any effect on the moment of inertia. Only the terms which affect the moment of inertia of any body is the mass, total mass, and the total radius of that body. So students, it was the moment of inertia of the disk, in which we have discussed about the solid cylinder and or the disc, in which has length capital L and radius capital R. First we divided this solid cylinder into many shells, into many small shells, and we find its density and its mass dm, which was here dm is equal to rho n to L 2 pi r dr, and that was we find the mass of the that shell, and from that mass we find the moment of inertia. From the equation of moment of inertia, we put that mass over there, and then we calculate that, and then after that we take total volume of the cylinder, and by putting total volume in the density equation, we find that the moment of inertia of solid cylinder or disk is equal to Iz is equal to half mr, which was unaffected by the length of the cylinder, of the length of the disk. Mean if you have a flat disk or a long cylinder, then both will have the same moment of inertia.